started the live stream. Okay, cool. So that usually is the first question, right? So what is a platform orchestrator? Um, the very short version of that is that there are tools on the market that actually deploy software, yeah, workloads, and there are tools on the market that provision infrastructure. And a platform orchestrator is dipping into those two domains and unifying that. So as a platform component, it is able to first provision infrastructure, learn from that provisioning what the configuration should be, and then configure a workload before it actually deploys the workload. And as such, will get you to one consistent deployable that is landing inside of a landing zone. That's what a platform orchestrator does. And then a ton more things, but we'll probably learn about that during the rest of the demo. So let's take a look at of how it looks for the Humanitec platform orchestrator. This little picture here shows a little bit who's contributing. Yeah. Left-hand side, we have platform engineers, and they are actually configuring the orchestrator. So all of these things. And then we have developers who are bringing the workloads that get deployed, hopefully. So they are shooting that in, using the configuration that is then forwarded to a runner. And all of that leads to the fact that a Terraform or OpenTofu run is executed, creating the infrastructure and the deployments. The main distinction between the two sides here is platform orchestrator. That could either be our SaaS variant, where we host and run the orchestrator, or it could be the self-hosted version. Then this customer infrastructure box would probably be reaching over here. Yeah, but the right-hand side, the runner, that one is always, in any case, executed in your own infrastructure. And that is very important because that is the interface towards any kind of secret manager, for example, intellectual property in form of images that get deployed, etc., etc. Yeah, so all of that should stay inside of your own networks with no chance to ever get exfiltrated. And that's how we roll. For today's demo, I'll be using the SaaS version of the orchestrator. Yeah, but they are functionally equivalent to the self-hosted version. They're essentially the same code base. Yeah. All right. So now that you have a first idea and glance of what is happening, let's dive into all of those configuration items or things that fly around here, which basically form the object system of the orchestrator. Let's take a deeper look at that before we jump off into the actual demo. So if you want to do anything like I'm doing a little bit later down the road, then you can come here, request a demo, go to the first deployment tutorial, and then execute the same code that I'm executing. For the explanation, I have to scroll down a little bit, find this orchestrator object landscape box, and open it up. So let's do the same trick. That's not so good in this case. Okay, let's see. So first we start on a project. A project is basically a binder for environments, and as such, it contains 0 to any amount of environments that you like. Those environments are of a certain type. Think development to production, or probably you have a different taxonomy for your environments. We don't care. You could do APAC, EMEA, and US environments. We don't care about that. You define your own taxonomy. And then an environment contains deployments. They are created by a deployment manifest, and those deployments contain active resources. Yeah, active resources are also typed by a resource type, and the deployment manifest uses those resource types to describe what a developer wants. So if we have the what, and we have then active resources which represent actual infrastructure, how is that actually being constructed? Well, They are created by Terraform modules or modules. Yeah. And while the resource type is an interface that describes the what for the developer, it also is the interface to describe the how in form of the module for the platform engineer. Yeah, and as we are talking about Terraform modules here, they are using Terraform providers to actually create this infrastructure, and all of that is executed on top of the runner that I already mentioned. All right, so that basically describes the process and all of the moving elements. But it would be pretty anemic if I wouldn't show you the process live, right? So let's start on a case that is the lowest entry barrier that we have for that. And that is a good old GitHub repo, a template repo that I'm using here to simulate the start of a product or project. So I'm basically using this to simulate a scaffolding capability, but in a low-key form because I don't want to have a scaffolding framework or a developer portal or something like this here, right? As easy as it gets, but end to end. All right, so we got a repo here that contains some source code, which is built by this Docker file, and that is motivated by GitHub Actions-based pipelines, which sit up here. But before that Docker file is then motivated using this Helm chart onto a Kubernetes cluster, it definitely needs some infrastructure because without it, it wouldn't be happy. And for that, we do have this manifest.yaml. So going in here, you will see your first deployment manifest. We're talking about a workload called main here, and that actually has some resources, one of them being a bucket. And as I said, this is just the what, not the how. So all we know is there's something named bucket and is also of type bucket. And because I want to be able to transport this later on to my application as configuration, I do have an output here called bucket name, which is using this placeholder language to actually siphon off the name from the resource bucket and putting it into this output, which can be picked up in a values file and then used to configure the Helm chart so that everything clicks together seamlessly. And hopefully I've been talking for long enough, then we can see this live in action. But one thing first, I was saying that it's all about the what, not about the how. And if you take a look at those two entries here, account and namespace, they are literally a little bit about the how because they already tell me, hey, somebody's targeting a Kubernetes cluster here. And also I have some things, or I have at least one thing, the namespace, that is literally table stakes. Yeah. So does this really need to be in here? Well, the answer is no. But currently they're in here to show you that you can self-adjust the level of abstraction that the orchestrator puts in front of the developer as an interface. So in the next example, they will be going away, although I'm still deploying to a Kubernetes cluster. Okay, now I hopefully have talked for sure long enough. Scaffolding is done, release is running. Let's take a look at the details. I hope. Oh no, we need to get here, wait for service, wait for service and show URL. Before that, I can't show you the outcome. So run GitHub run. At least I have time to get the bag out of my tea. And take a look at the chat. Ah, Fabio from Italy. Nice to have you. Buongiorno. So here we go. The app is ready, so I can open this up and show you the very German demo app. It's just a gray screen. Sorry for that. But it displays this second called demo bucket. This is the actual name of the bucket that has been created on the cloud. Yeah. And as you can see, I've already done my job. There is a queue name that is unspecified, which means I've had another development iteration. And now my application is waiting for the next piece of infrastructure to be connected. So let's take a look at how easy it is for a developer to actually procure more infrastructure that is not coming along as part of the scaffolding. And it is so easy that I'm literally staying in GitHub here because I don't want to check out this stuff and put it in an IDE that would just be, yeah, overscaled for this. So I'm just clicking on the edit button for the manifest in here. And what is a good name for a queue? Let's do, I don't know. I feel like yesterday we had something very different. Let's do something completely different today. Agamemnon, why not? Agamemnon the queue. All right, and for that, now I'm simply copying this line here to make my life a little bit more easy. Obviously, we want to have a queue name this time. And from the resources, I want to have the one called Agamemnon to lend its name into this output. And that's all it takes. Let's commit those changes, trying to be my work self here. And I'm starting a new branch for this commit and a pull request. And while this pull request is running to completion, yeah, because creating this pull request will trigger more pipelines to run, we can take a look over here at the orchestrator. Reloading shows my JTest 101 project is here, and I do have a default environment. Going into this default environment, I can show you the resource graph for the first time. So this is what the orchestrator actually makes out of your deployment manifest. This is your application architecture come to life, so to speak. And in this case, you see only things that have been part of the deployment manifest. As a platform engineer, you can influence the configuration for the orchestrator to put more things on the graph because they are needed according to the specification of the golden paths that you prepare for the developers to tread on. Yeah, but we'll take a look at that in the next example as well. Currently, we just have Bucky the bucket here, our service account, and the namespace. Yeah, we can see that has been successfully deployed, and hence the reason that we do have this gray app here. All right, so now hopefully this pull request here is actually gone through the scaffolding phase. Yeah, and you can see that there is a very suggestive name here. It says deploy to ephemeral environment. So what does that mean? Yeah, reloading this here does not net me anything new. It is still the state from before. But if I go one level up into my project, I can see that I now have two environments and one is named very suspiciously ephemeral PR1. So going in here, I can see it's still deploying currently, but in here I do have the bucket, but also my queue called Agamemnon. Right, so why? Well, the answer is simple. When I created that pull request, the CI system did kick off a different pipeline and told the orchestrator to not deploy this into the development environment, but instead to create a bespoke environment for this so I can test this in isolation. Imagine me now running a long-running integration test suite, which does not want to be interrupted. And if I would have some more developers on my team that also wanted to deploy their change sets onto development, yeah, well, then we could step on each other's toes. But having ephemeral environments at my disposal actually removes that problem from the map. And quickly taking a look over here, this is still running, but we can go into that run and see we are very close to completion. Hopefully. Here we go. Whoop. So we can open that one up as well. And this time you can see that we do also have a queue. But as this is a completely bespoke environment, this one here starting at 35234, this one over here starting at 3440, so different URLs. And also I can reload this one. The queue is not going to come up here. Yeah, so why was this so easy? Well, if you think about it, all of the code or the configuration that makes up an environment is actually stored here in this manifest.yaml. Yeah, this is not the pull request version, so Agamemnon is not in here. That's living in a branch, right? Um, yeah, but that makes up all of the configuration for an environment. As a developer, I do not need to create a bespoke configuration. I can simply hand over that manifest to the orchestrator, and the orchestrator knows how to compute all of the needed configuration and create a new environment. So that makes it very easy and cheap to get those things. So let's hop over here and take a look at the pull request, because I think that I've done a great job as a developer. Everything looks to be in order. So I'm going to do a bad job as a developer by merging my own pull request here, stepping out of best practice land, but it's just a demo session, right? I feel confident about that, so I'm deleting the branch immediately, and that's my job done as a developer. But as a platform engineer, I feel slightly intimidated, at least, because a robot just created a lot of infra. Yeah, it's bespoke environment. Who's going to tidy all of that up? Oh, well, probably the same robot. And that leads to the fact that if I take a look at that environment, I can see there's a deployment running currently. If I take a look at the deployments, I can see the currently running one is in destroy mode. So as soon as this has executed, the environment will be gone. All of the infrastructure will have been collected, and all of the cost will have gone as well. So that should have happened in a short time. And then also here, the default environment, I only see those 3 nodes, but as soon as the merge back to the main branch has kicked off another deployment, we will see Agamemnon appear in here. All right, not going to wait on that. Yeah, we're going to close that down. And instead, we're going to leave our bucket here and our queue and the whole scenario, because I want to change paces a little bit. Up to here, I've been showing you mainly the developer view, so you have an idea of how this looks and feels from the outside. But the next thing is going to be more along what a platform engineer actually does. So over here, you can see in the Humanitec org clear code, I have prepared a project with this ID, and all of that has been terraformed, and that did take 6 minutes. As you can also see, this is happening in Azure here. So that's what's on the menu for today. Right. So let's head over to the orchestrator. See if I reload this. We can see Agamemnon appear here in my default environment. And that means reloading this here now will actually get us to the queue name as soon as the cloud has decided that it wants to pick up the new version. Okay, so that's still running a little bit. I don't care about the repo. And let's change to my clear code organization in the meantime. Here's the tutorial project, and there are 2 environments in here. Both of them have not been deployed. They are royally empty, as you can see. Let's change that, but this time a little bit more in platform engineer style. So I'm maybe developing a new version of a module or some Terraform code, and I want to see if the orchestrator can actually execute that. Yeah. For that, I'm going to use HCTL, which is our own CLI, and we're going to deploy into this project here, into the Azure Dev environment. We're going to deploy something that I know is here, this manifest2.yaml. Yeah. And executing this will actually tell me that the project and environment are existing, but there is no last deployment, as you've already seen in the UI. Yeah. And that means generating a diff to nothing means we are deploying our demo app. All right, let's do that. So this is now executing in the background. And taking a look over here, if I reload that, I can see what we will get. We will get this workload. which is a so-called SCORE workload. It will have a Postgres database, and those things are still going to Kubernetes. They are going into two different namespaces. All right. So while this is running, it's already completed. Let's take a look over here. Now reloading should actually get us, there we go, the topic. So all of that has happened. I'm not allowed to cheat here. And that's the reason I wanted to show you that. Okay, so this is our new graph. Yeah, so let's take a look where this is coming from. And that is coming from manifest2.yaml. So this is actually the file that led to the outcome you can see. So inside of our demo app here, we have two resources. One of them is the SCORE workload, which is deploying this container here. And the other one is down here, a DB of type Postgres. And we are forwarding the Postgres connection string using the placeholder syntax here into the demo app. And that's the reason why it can connect to the right database later down the road. But the question obviously is, why are there namespaces? There are none in this example, right? So where are they coming from? We'll take a look at that as soon as I have kicked off the next deployment, because that's probably going to take a little bit longer, and I just want to start it before we take a look at the insights. So for that, we will do an hctl SCORE deploy. SCORE is actually a platform agnostic and environment agnostic workload specification, which is hosted by the CNCF, which is also understood by the orchestrator. And this time we are deploying to the Azure SCORE environment, and we are deploying a score.yaml. I'm not showing you yet what this looks like. That would already be telling. Yeah, we're just going to deploy this in the background. This is running here, and we're going to take a look at why there are namespaces on the graph. Right? So those two, where are they coming from? So the first thing you will see is that I'm actually able to put metadata anywhere where I want to in the graph. In this case, I have annotated the SCORE workload. Haha, it thinks it's still deploying. So let me reload that. There we go. Now I can show you the metadata that is only known after the deployment, obviously. So sorry for that. My home network and WebSockets that automatically refresh this website in the background are sometimes no good friends. So as you can see, there is this metadata. I actually added that here. So I can tell you like, okay, this is the namespace name where this was deployed. This is the name of the service. But I could put any kind of metadata here. Yeah, I could query third-party systems. I could actually construct a link and display it here so that I could jump off to a third-party system like an observability tooling. Yeah, and the only link that I currently have is this one here, but this one is going to the module that actually is used to implement this. So let's take a look at that one. And this is the first module definition that you'll see. So we are wrapping a Terraform module here that lives here under revision control. That is the Terraform module. And we are having a dependency here on a Kubernetes namespace. And that is the reason why it appeared on the graph, because we're telling the orchestrator, hey, I do have a dependency. This is non-negotiable. I need to have one. And because of that, the orchestrator will simply put it on the graph. Yeah. And will also form the dependency as you've seen it, right? There is, from the SCORE workload, an arrow going to the K8s namespace. And you can read that graph very easily. The dependencies flow from left to right, and that means provisioning later down the road flows from right to left. Yeah, because as it is a dependency, this needs to be here, this Kubernetes namespace, before the workload can be deployed into it. And that also means that this Postgres database needs to be there before the workload can connect to it. Yeah, so the deployment order would be this namespace first, then deploy the Postgres into that namespace, then create this namespace, then deploy the workload into that namespace. Yeah, so that's how this graph works. It models the real world, and as such, the statement is true that this is your application architecture come to life. All right, so this is a dependency, and what you can also see here is that there are different ways to convey information to the underlying Terraform. We do have module inputs. This one here is, for example, forwarding the namespace name to the Terraform module. And inputs can only be provided by platform engineers. But we do also have params, and params are actually able to be influenced by developers. So there's a clear separation of duty here. And as a platform engineer, I actually define how that looks like. And that, for example, gives developers, in this case, the opportunity to bring the container as it is specified here. Yeah, look, there is params, the container. And so I can say what should be deployed as a developer here. That's how these things click together in a very straightforward way. So as a developer, if I don't understand how something is looking like or what inputs I can actually influence and provide, I can simply go here. So now the one thing that we are missing is this tab up here, and those are the rules. Under specific circumstances, it would be great for the orchestrator to understand what the right outcome is. Yeah. And that is how platform engineers convey to the orchestrator when the right how is being used, so to speak. Yeah. In this case, if a resource of type score workload is requested and there is no other limitation here, yeah, then this here should match. And if this rule set is fulfilled, then this here should be used to provision a resource of type score workload. Of course, there are different cases where it makes a lot of sense to match more close, yeah, or constrain more, and then have different outcomes. For example, you could have two definitions for a Postgres database, and you could constrain that on the environment type. One is for all environments of type development, and the other one for environments of type production. In development, you're probably okay with having a container running in a Kubernetes cluster that's cheap, that's quick. And if it explodes, you really don't care because the next one that is preloaded with your development test data will be there 3 seconds later. Probably not the best strategy for production though, and hence the other rule set attached to the other resource definition, which says that if somebody's asking for the same thing, a Postgres database, but in a production environment, now he's getting a DB as a service from a cloud provider, which is highly available, geo-distributed, backup to keep RPO and RTO in check, etc., etc. Yeah. And the matching system or the rule system of the orchestrator allows you to have this segregation in a very straightforward way. So having said that, let's take a look over here. Our first deployment did actually not take that long. Yeah, going up here, it was done after 25 seconds. Our second deployment did take almost 3 minutes and 10 seconds longer. So this was deployed on the first run. And please take a curious look with me at the score workload here, from here to there. Now I show you what has been used to deploy the second run. And that actually was this score file, which looks eerily the same like what you've seen up here. Minus the database, mind you, because I didn't want that thing to deploy even longer. So that's what you got. All right, so why did it take so long? Well, the simple answer is, if I take a look at my resource types, score workload is here for sure, but that is just the interface, right? I can have many modules implementing the same type. And taking a look at my modules, this is exactly what's happening here. Score Kates, the one with the dependency on the namespaces, was the score workload that was used on the first deployment. But up here, we have another score workload, which is called Ansible score workload. So going in here, I can see that this time it has a dependency on a VM fleet. So a fleet of virtual machines. And taking a look at the rule set, I can see that now here's a constraint. If the environment ID is Azure Score, then this one here should take precedent. As it is constrained, it matches more closely if all constraints apply and takes precedent before the more generic one. Taking a look over here, sure enough, when I deployed, I asked to be deployed into the environment Azure Score, which is exactly the environment ID I was looking for. And that's the reason why something very differently happened this time. So going back to the project and the Azure Score environment, also the graph looks different, obviously. I do have my Score workload still, but this one is connected to the VM fleet as, yeah, already said. And let's take a look now at the outcome. Yeah, what happened? Let's do AZ VM list. As you can see, there are 3 VMs here. And let's change the output to JSON for a second. As you can see here in time created, this one is in Zulu time. So we started those 8 minutes ago. Yeah, so once again, no cheating allowed here. And I want to do an AZ account list because I somehow seem to not remember my tenant ID correctly all of the time. Because who doesn't like to memorize UUIDs, right? But this is the shortest way for me to show you. Okay, that's the resource group. There is the VM fleet. Taking a look at that here. This is the resource group, VM fleet 5A1 ending in A8, 5A1 ending in A8. That seems to be the one. And taking a look in here, I can see 1, 2, 3 virtual machines. And I can also see a fleet load balancer and a public IP address associated with that. So let's copy the IP address and take a look at that. Because there's a load balancer in front of our virtual machines. Let's change the refresh to 1 second. You will see probably that there is a change between 3 different background colors because the background color is chosen randomly at deployment. Wow, that is green. Nice. Yeah, and if you're not on Azure, like I am today, the Azure load balancer is not using sticky sessions, but it's also not going round robin with every refresh. Yeah. If we would be on AWS today, then this would be what I call disco demo mode. Right. But there is lavender or something. We've already seen very green, and I think there was a bluish color as well. So yeah, that has deployed as expected. Yeah, there we go. The third one. All right. So, and that actually concludes my whirlwind tour of the main features of our V2 orchestrator. Yeah. Access to things like ephemeral environments comes basically for free. A clear segregation of duty between developers who just write deployment manifests and have a very abstracted interface to access golden paths in a fully self-serve way. And on the other hand, platform engineers that add the how to those golden paths in the form of Terraform modules and module definitions, orchestrator configuration that allows for the developers to just ask for the what and the orchestrator to ask, so to speak, for the how and combine both at deployment time. And we are not only constrained to Terraform, yeah, but we can also utilize any other kind of ISC that can be triggered from Terraform. And that's exactly what I've done here, because if you go into the module, the second one was called Ansible Score Workload for a reason. First, I use, if I take a look at the graph first, wait. First, I used Terraform inside of this VM fleet here to procure my three virtual machines. And then the score workload is now depending on the Ansible score workload. And that means it's using Ansible to run an Ansible playbook against those three, actually putting a Docker daemon on top, and then deploying the same container that I deployed before to a Kubernetes cluster, putting the load balancer in front to make it accessible. So as a developer, I don't need to understand where this is going to be deployed. I can simply ask the orchestrator to deploy to the right environment for me, and all of the rest is being figured out by the platform and taken care of. And that is also one of the new main features of the V2 orchestrator. It is not just targeting Kubernetes this time, but we are able to deploy virtual machines, as you're seeing right here, or serverless, or basically anything else. I have very interesting projects with customers that, for example, do hardware in the loop development, where there's some strange blob of hardware sitting on the developer's desk. And now firmware and developed software needs to deploy it onto that thing, which is connected to the development notebook. But somehow the deployment needs to come from the cloud over the orchestrator into that hardware. And these kind of things are totally possible with the V2 orchestrator as well. Right, so any deployment surface, almost any ISC language that you can think of, any cloud, any local or more local scenario like a data center, like hardware in the loop, everything is possible with V2. Now, what I can't do, because I want to be respectful of the timeline, is that I can go into more depth or more breadth with you. The system is just too large to show you everything. But what I can do is I can show you that on our website, humanitec.com, you can simply go to use cases, for example. And in here, you will find a few very interesting use cases, also with a video demonstration where you can tap a little bit deeper into scenarios like rolling back applications and infrastructure. How do I identify and fix infrastructure drift? How do I understand the blast radius of a deployment before I actually execute it, before I pull the trigger? Yeah. All these kind of things, we have prepared that. So if you are interested on how to make that happen, you can dive a little bit deeper here. And of course, as we have not only a few minutes left, but also at least in my timeline, quite a little bit more, I am happy to take any kind of question that you want to throw in front of me now. So, Antonello, I have not taken a look at Q&A. Is there anything in there?
Not at the moment. So let's wait a few
So
minutes if
muted.
anyone. Can you hear me now? Yeah, let's wait a few minutes for the question. If there is no question, you
Still on
can
mute.
answer. Yeah. Still on mute?
Or is that just me who can't hear him? All right, I can at least read the first question in the chat. Does the platform support any form of automatic drift detection and remediation? Well, catch and fix infra drift, that scenario here, that would be made right for you. So yes, there is a way to actually catch infrastructure drift and make it actionable. Yeah. Actionable in this case sometimes can mean automatic remediation. Sometimes that's just not the right thing to do. To give you an example, in case of a production incident, I might actually jump onto the system and do some manual alterations. Yeah. Of course, they will be detected as drift. Yeah. But remediation would in this case not be to make the drift go away in an automated way, but instead the configuration of what the orchestrator perceives as the desired state needs to be adjusted so that the drift goes away by making the perception of it go away. right? Because I for sure don't want to remove my fix from the production system. I want to keep it up and running, right? In other cases, I might catch drift and then simply tell the orchestrator to just do another deployment, which will make the infrastructure drift go away because it will remove it. Yeah. So at this time, we are working on making this a little bit more automated. Yeah. And you can see how that looks like here in the catch and fix infradrift scenario. All right. So let me see if I still can't hear you or you're not talking. So if you have anything, just put it in the chat.
I don't know if you can hear me now.
Mm. Oh, that's another very good question. Is it possible to import existing resources deployed using Terraform modules? Yes, it is. Of course. The question is just on how to get there, right? Importing Terraform modules is the more easy thing to do. As you can imagine, what you need to do is you need to write such a module definition. Yeah. For example, for Kubernetes namespace, where I do not want developers to choose the naming for that, where I have a convention in place, no inputs, no params. Yeah. I basically just say, okay, that's where the module is lying around. And this is the provider that I expect to use, and that's it, right? So that is a very quick to execute task. And then comes the question about the state. And that is a little bit more of a tricky question because you might have quite a few resources lying around already. And what we try to do with the orchestrator is we try to get all of those resources into one execution, which equates to one state file. And to be able to do so, we would need to gather all of the state from potentially different states that you have and import them into the one state that is the desired state for the orchestrator. And we are currently working on tooling to make that a very automated process so you do not have to do any handiwork there. So yes, currently it is totally possible, but it is still a bit of a manual process, but we are currently solving that problem for you. And then you will have some nice migration tooling that allows you to import those state files into the one state that the orchestrator holds very easily. All right. Antonello, have you successfully fought a battle with
I,
your microphone?
I'm not sure. I'm trying, but
No.
that feels like no, doesn't work.
All right. Happy to take one more question if there is anything left. And if not, whoops, I want to be respectful of the timing. I can see a raised hand. Sure. Just put a question into the chat. Or do you want me to unmute you? I think I can tune that. I can do that. I don't know. Yeah, threes. I don't know if I can allow you to unmute yourself. So at least I can't get it to work. Probably Antonello can. In the meantime, please just put your question into the chat, right? I'm happy to take it.
I think it was just wrong button.
Hit the wrong button. Okay, no problem at all. Okay, dokes. Then, as Antonello is not able to say his goodbyes, I'm probably saying it for him then. So, thank you everybody for joining us for a demonstration of the orchestrator's capabilities today. Um, I hope you had some fun. Um, and now would be a good time to hop over to the Humanitec website and click on the I want to start a trial button. Then take a look at the first deployment tutorial if you want to replicate what you have seen me do today and just dive a little bit deeper and explore the system a little bit more. There are no strings attached, so you can simply do that and have some fun for the next 30 days. It's all royalty free. The first deployment tutorial is completely open source and on GitHub. If you have any questions which come up, feel free to contact us. We are happy to talk about almost anything orchestrator and platform related. And with that, I wish you a wonderful rest of the day, evening, or morning, wherever you are on the planet. And hope to see you around next time.